Welcome to a new lesson. In this lesson we'll be using the sine and cosine ratio to calculate lengths. Let's take a look at our first example. Determine the length of line segment BC to the nearest tenth of a centimeter. So let's take a look at this triangle, and we're looking for the line segment BC. The first thing we're going to do is we're going to label the triangle with respect to the angle that's given to us, which is 50. That angle is always looking at the opposite side. The 90 degrees is always looking at the hypotenuse, is always opposing the hypotenuse, and the side that's left is the adjacent side. Then it's good practice for us to write the SOHCAHTOA, and through SOHCAHTOA we could see which trig ratio we're supposed to use. We know that the hypotenuse is 5.2, and we're looking for the adjacent side. So we're going to use cos to find our answer. Right cos of any angle, which is usually theta, is adjacent over hypotenuse. Now we're going to plug in the values we know of. It's cos of 50. Adjacent is we do not know, and we know the hypotenuse, which is 5.2. Then we're going to cross multiply the 5.2 with cos of 50 degrees is our adjacent side. As long as you're in degree mode, plug this into your calculator and you'll get 3.3 centimeters is our answer. Double check that the question says to the nearest tenth, and we do answer to the nearest tenth of 1 decimal point. Let's take a look at a second example. In this example, we're going to determine the length of DE to the nearest tenth of a centimeter. So let's take a look at where DE is. And let's label this triangle. Again, we look at the angle, and it always looks at the opposite side. So 6.8 is the opposite side. The 90 degrees always looks at the hypotenuse side. So our line segment DE is the hypotenuse, and the side that it's left is called the adjacent side. Of course, always write SOHCAHTOA in this situation, and it will again help us determine which ratio, which trig ratio to use. We have opposite, and we're looking for the hypotenuse side. So therefore we're going to use the sine ratio. We're going to write the sine ratio, sine theta. Again, Greek letters are often used to find the angles. Or in this case, because it is angle E, we could use the E letter. Again, that's opposite of opposite of hypotenuse. Plug in our values of 55. Opposite is 6.8, and we're looking now for our hypotenuse. And I'm just going to write in green. To solve for hypotenuse side, we're going to cross multiply, and when we cross multiply, we actually interchange the sine 50 with the hypotenuse. So that we get h on top, 6.8 on the other side, and down where h was before, sine 55. So we are actually dividing. As long as you're in degree mode, hypotenuse to the nearest centimeter is, nearest tenth centimeter is 8.3 centimeters. And this is our solution. Let's take a look at the last example. In this example, a surveyor made the measurements shown in a diagram. How could the surveyor determine the distance from the transit to the survey pole to the nearest hundredth of a meter? So we are looking for the distance between the survey pole and the transit to 100th of a meter. So with respect to the angle 67.3, we're going to label the triangle. This is the opposite side. The 20.86 meters is the adjacent side, and the side that we're looking for is the hypotenuse. Again, we're going to write SOHCAHTOA. We're going to determine through SOHCAHTOA, the little shortcut, which ratio to use. Since we're looking for the hypotenuse and we have adjacent, we are going to use the cos ratio. So now cos of any angle, or theta, is the adjacent side over hypotenuse. I'm going to plug in these values inside these unknowns. The adjacent side is 20.86 over the hypotenuse that we are looking for. And just for good measure, I'm going to write it in red. When we solve for hypotenuse, we'll have to cross multiply. I'm going to interchange the hypotenuse with the cos, 67.3. That means hypotenuse now is on the other side, but on the top of the numerator, while the 20.86 is on top, and the cos now is at the bottom as a denominator. So I'm in degree mode, plug this into your calculator, and make sure you double check the question asking for nearest hundredth of a meter. Therefore, we'll have an answer 54.05 meter as the distance between the survey pole and the transit.